My name's Ian Hutchinson. I'm a professor of nuclear science and engineering at MIT. I'm actually a plasma physicist by training, and my research has been focused for most of my career on bringing down the energy source of the sun and stars to the human scale to try to make that energy available for us on Earth. Well, my research involves the physics of incredibly high temperature gases, and these are called plasmas. And the reason why we care about that is that in order to make fusion reactions take place, we need those very high temperatures. The stars, the sun, function on the basis of nuclear reactions which take light elements like isotopes of hydrogen and fuse them together. That happens only at very high energies and high temperatures. And so understanding how those incredibly hot plasmas work is a vital part of understanding whether we can make fusion energy on the human scale and make it available to individuals and to society. So energy from nuclear reactions can be released by us in two main ways. The energy source that we currently have, nuclear energy, takes heavy elements like uranium, and by breaking them up, this releases energy. And that's how our current nuclear power works. Fusion is, in a sense, the opposite. It's taking light elements that have very few protons or neutrons in them and fusing them together to form heavy elements, and it turns out that that also releases energy. And the advantage of fusion is that it doesn't give rise to very radioactive fission products, and so the radioactive aspects of a fusion reactor will be greatly reduced relative to a fission reactor. It also has certain potential advantages in respect of safety, in respect of control of nuclear materials and therefore weapons, proliferation prevention. The big disadvantage of fusion is it turns out it's much, much harder to do. And that's why we've been working on it for so long, and it's taken us so long to reach the point of proposing a scientific demonstration of fusion energy.
The sci-fi world has cold fusion or something like that.
Yeah.
Is that a thing, or is that just...
Okay. Yeah, people do often ask about what is cold fusion. Cold fusion is an idea that got going in the 1980s that perhaps fusion reactions can be made to work at much lower temperatures than our basic science seems to show. As far as anyone in the fusion business is concerned, basically that was a mistake. It took us a while to prove that that was a mistake, but from my perspective, cold fusion is simply the outcome of an error. It's an aspiration which isn't consistent with the laws of physics as we know it. So those of us who are in the mainstream of fusion research are studying, if you like, hot fusion involving these very hot plasmas. How close we are to fusion energy is, in a certain sense, reflected by this big experiment, ITER. If ITER is successful, it will have made a scientific demonstration of fusion energy, but that'll be a long way from putting electricity on the grid, because in order to do that, we need to engineer the magnetic bottles so that they can run day in, day out, round the clock and generate electricity. And so there's all sorts of engineering that has to be done. And then there are questions of economics. Is it going to be economically attractive to do this? So I think that I'm rather confident, although somewhat disappointed in the fact that fusion energy will not be on the grid in my lifetime. But I do think it's a very valuable and important long-term aspiration, and something that I'm happy to have spent a career on. So there is a second way of trying to make fusion energy work on Earth, and that is, instead of using magnetic fields to confine the plasma, to use essentially just the inertia of the plasma. And this is called inertial fusion. And what it does is it takes lasers, it concentrates very high power energy onto a small pellet of fusion fuel and causes the reactions to take place so quickly that they take place before the pellet flies apart. Actually, what this amounts to is a small-scale explosion. So inertial fusion actually has an important relationship to nuclear weapons. In fact, the reason why the research is mostly done in national labs in the US is because its relationship to nuclear weapons is so close that some of the physics is secret. But it is an interesting approach. Its advocates would argue that it can in fact be used to generate electricity and useful energy. I'm perhaps a little bit more skeptical about the engineering aspects of inertial fusion than I am about magnetic fusion. It's challenging in both cases, but I think that magnetic fusion is, in my opinion, more likely to come up with a usable energy source. Is nuclear something we should avoid? I think fusion has potential advantages, which I've just mentioned, with respect to fission in terms of its attractiveness and its safety. But I am not personally persuaded that the media and societal opinions that have led in some countries to abandonment of nuclear energy and in other countries to slowdowns in its usage, I'm not sure that those are well judged. I think we're going to have to use a whole spectrum of different energy sources if we're going to wean ourselves away from burning fossil fuels, which most people think these days is extremely important to do for the climate and for the future of the planet. And so I think to rule out fission energy, which is a proven source, it's a safe source, it kills far less people than mining coal and burning it or gas for that matter, and burning that for generating electricity. So I think there's an imbalance in the way that nuclear power generally is seen in our society. And while there are some terrifying things about nuclear weapons, certainly, and for some people about energy generation using nuclear power, I think this is hyped in the media and in people's minds far beyond what a sober assessment of the safety characteristics of nuclear power actually are. Well, I am stimulated by the intellectual challenge of understanding how these very complicated gases of ionized particles work, and because plasma physics really dominates much of the physics of the galaxy, of the universe, of space between ourselves and the sun, space weather, and a lot of technology on Earth, for example, the processing of semiconductors is all done with plasmas. So plasmas are of themselves of great intrinsic interest for our understanding of nature. But also, I'm very much attracted by the idea of trying to do something with my science that has benefits for humankind. And I think the challenges of energy production, in particular energy production which doesn't give rise to carbon dioxide and other polluting gases, is of tremendous importance. And so that naturally motivates me to have done this research and to continue to do it. In an idealized situation, the way this would work is the fusion reactions take place, they emit energy, we collect that energy together and heat up some kind of turbine fluid that we drive electricity generating turbines with, and that puts electricity on the grid. So ideally, fusion would replace the fossil fuels and other electricity generating schemes that we are currently using predominantly for generating electricity at the moment. as far as we can tell, it isn't possible to do fusion and produce energy on a very compact, a few centimeter or meter scale for various fundamental reasons. So it's probably the case, that Mr. Fusion in the back of your DeLorean car is never going to happen. But we certainly can replace fossil fuels for generating electricity and providing other kinds of heated energy. Well, I became a Christian when I was an undergraduate at Cambridge University, as my accent probably betrays. I grew up in England. So actually, there is a sense in which I was already embarked upon a scientific career, or at any rate scientific study, at that time. It was an important development in my life, and there are a whole host of influences that went to bring me to the point of becoming a Christian, committing my life to Christ. But I think science was certainly not a restrictive influence, or it wasn't an influence that drove me away from Christianity. Very far from it, I think. And I think subsequently what's happened is both my scientific understanding of the world and my spiritual and Christian understanding of the world have sort of grown up together. And I think that might be one reason why I'm very interested in the relationship between science and Christianity, and I've done a lot of speaking and writing about it, and I think that I have a balanced view of that, in part because of my history. Well, obviously science has grown enormously over the past 500 years, and we now understand vastly more about how the natural world works. And that does have a tendency, perhaps, to lead people to depend on science and on technology for their safety and for their food supplies and for their health and so on and so forth. So there is a sense in which today it's natural enough that modern people tend to depend upon science for a lot of things that in the past were completely out of people's control, and all they could do was pray about it. But the more fundamental question is, has science displaced, or has it ruled out a faithful stance? And I would give the definite answer that that clearly can't be the case. I mean, in the first place, the early scientists, those scientists who were responsible for the scientific revolution, were predominantly Christian people. Certainly for them, science, adopting an understanding of the natural world based on explaining nature naturally, did not replace their faith. It supplemented it. It helped it in many respects. And I think that's actually also been the case that I've seen in my interactions with people in universities and so forth. Actually, if you ask who are the Christians in universities, you find that actually scientists are not underrepresented amongst Christians in the university. They're actually, if anything, overrepresented. It's the scientists that tend to be the Christians, and it's the sociologists and politicians and humanists, people in the humanities, who tend less to be Christians. So I think that the impression that many people have got that science somehow is so incompatible with Christianity, with spiritual view of the world, is simply a mistake. It just isn't the case factually. Whether it should be or not is a much bigger question, but I certainly think that, and this is the title of my book, that a scientist can believe in miracles, can believe in a God who acts in the world, and I certainly do. Well, scientism is a word that's used to describe the view, very simply, that science is all the real knowledge there is. That's slightly an overstatement, but that's the simplest definition. In other words, it's the idea that if you want to find out anything in this world, you should use the methods of the natural sciences. And I think this is very important in the question of the relationship between science and Christianity and spirituality generally, because I think scientism is what leads some people to think that religion is a waste of time because they think it can't possibly be knowledge because it's not science. But scientism itself is a dreadful mistake. It's just simply an intellectual error. It's not the case that a discipline like history, for example, uses the methods of the natural sciences. It simply doesn't, because it's dealing with unreproducible phenomena. Most of the interesting things in history are not reproducible. You can't do experiments to prove them, and that's what science depends upon. And also, history deals with things which have enormous nuances, and they have a large amount of ambiguity, whereas the natural sciences work on insisting on a certain clarity of expression that is given to us by measurement and mathematization and important other disciplines that give crystal clarity. And so it isn't the case that even as something as simple and widespread as the study of history verifies that scientism makes sense. So actually there are lots of other disciplines in the humanities and social studies that don't use the methods of science. And so I'm very comfortable taking the view that science doesn't prove there is a God, that actually we don't use the methods of science, for example, in theology, in thinking about God and understanding God, because science isn't all the knowledge there is. And so there can be real spiritual knowledge, in my view, even though it's not scientific. Well, I think this issue of relativism, which is very widespread, in the academy, but also in society as a whole, and that might be, in a certain sense, the predominant viewpoint of young people today. I think that springs from the academy having been incredibly strongly influenced by postmodernism. And there is a sense in which postmodernism simply discards all grand narratives, as it calls them. In other words, big pictures of the way the universe or life or everything is. Postmodernism says these are never true, that the local narratives are the important thing. There is a sense in which I think postmodernism sprang from a reaction against scientism. So the earliest postmodernists who essentially promoted this idea of recognizing that the relative difficulty of establishing our knowledge were emphasized as much as possible. They were emphasizing as much as possible that science is not all the real knowledge there is. So I take the view concerning postmodernism that postmodernism is a reasonable reaction to scientism. It's to push back against scientism and say, no, there are lots of other important things, the ways we understand our lives and about the world. The difficulty is that postmodernism very often throws out the baby with the bathwater. The bathwater of scientism deserves to be thrown away. But science itself does give us real knowledge, reliable knowledge about the world. And by the way, so do many other disciplines give us true knowledge. And so I think there is such a thing as truth. We are perhaps in a position of recognizing that it's more difficult than perhaps some of our forebears thought it was to arrive at it. But I certainly don't take the view that there is no truth. And I certainly take the view that Christianity is deeply true. I think one of the things to recognize is that bizarre things happen in the lab all the time. They're usually just mistakes, but that's something that you put aside in scientific research because what you're looking for is the reproducible type of events. I think one of the highlights, let's say, of my scientific career has been to achieve, records of the highest confined pressure in a magnetic confinement device and so forth like that. Those are easily understood, world record type of achievements that I think are lots of fun and we can be proud of. Actually, I think, though, for most scientists, there are moments when you begin to realize that you're thinking about something in some totally different way. You discovered something new. You've seen a phenomenon that nobody else has ever seen before, or you've developed a theory that no one has ever formulated before. Those moments, those aha moments, are certainly one of the highlights of a scientific career. I think for someone like myself, there are moments when I pause and I give thanks to God, and I say to the Lord, that is a marvelous design. That's a marvelous phenomenon. Glory to God because of it. I don't actually think being a Christian necessarily makes you any better at having those aha moments, although I think there is a sense in which my understanding of God inspires me in my scientific research. But being a Christian isn't a shortcut to being a good scientist. But I think there are moments when as a Christian and a scientist, you can step back and see the glory of creation, which reflects the glory of God. In general, I find the majority of my colleagues are very comfortable with my spiritual commitments. I'm not forever grasping them by the lapels and saying, "Are you saved, brother?" That's not the way I work. But they do know that I'm a Christian, a serious believer, and so forth. And I'm happy that they do. And on occasions, they'll ask me questions about my faith. And on occasions, colleagues, professorial colleagues, or students for that matter, will come and share with me or ask me questions because they know I'm a Christian. They'd like to know what my opinion is about certain types of things, or can I advise them? Or I've even had Christian students come to me and share some of their difficulties with me, and on occasion I might even pray with them, but that's relatively rare. So I think that in general, my scientific colleagues are very open about my scientific faith. I'm not unique by any means in being a Christian in science. In fact, in my field, in plasma physics, at the annual meeting of the Division of Plasma Physics of the American Physical Society, there is always a meeting in the early morning of Christians who want to get together and share their faith together, who are plasma physicists and are at the conference. So, there's a plasma Christian fellowship. So I think in general, it's a sign that people in the sciences do recognize that it's perfectly possible to be a committed Christian, a person who believes in a God who acts, and to be a first-rate plasma physicist or first-rate fusion researcher. And that's, I think, comforting, and I think it's a fact. Well, one of the reasons why I spend quite a bit of time speaking to university audiences, students, and sometimes churches and other audiences, is to help people to understand that the myth that science and the Christian faith are incompatible is indeed a myth, and to encourage people, scientists, to recognize that Christianity does not threaten their science, and indeed I think that's becoming better understood, but also to help Christians who might feel threatened by science to come to peace with science and understand their faith is not automatically at loggerheads with the findings of science. Of course, there are tensions from time to time between these two that have to be worked out. But our forebears in the faith and in science took the view that God has revealed himself through two books, the book of his word and the book of his works. And I feel that that metaphor is one which we need to recapture today, and to bring those two books together and work out the ways in which they mutually help us to understand both revelations.